Hello! Today we are going to talk about surface area. Surface area is what we consider like when you're wrapping a Christmas present, it's the wrapping paper that you use on the outside of the package. It's what we would think of as the skin of a three-dimensional shape. Remember that when you find the area, there's lots of different formulas that we learned. You're going to be using those different formulas to combine and add up to get the total area of a figure. When we do surface area, we also need to understand that a cube or a rectangular prism or really any three-dimensional shape can be flattened out into a two-dimensional shape by creating a net. Now, yesterday I gave us all this three-dimensional shape that we put on page 37. This is actually an example of a net because it is a three-dimensional shape that I can fold up to make a cube, like so. But I can also, in order to figure out the area of it, I can unfold it, and then I get it as it's a flattened out three-dimensional shape, and that it makes it easier for us to find the area or the surface area of the whole shape. And when we do flatten out a net, it tends to look more like a composite figure or an irregular polygon, which is what we've already done. So for right now, we're just going to leave on 137 this three-dimensional shape. We've glued it down. We're just going to leave it there for the time being. We'll come back and use that later to practice. We're going to head over to 138. And we're going to review the topic of surface area. We're going to answer the essential question, how do I find the surface area of a three-dimensional shape or a 3D shape? And the first thing that you need to know is, I'm going to give you a second to write that down. And now we're going to start writing down what is lateral area. Lateral area is basically the flat side of a three-dimensional shape. It's the type of area that we've been already practicing. And you'll notice that in three-dimensional shapes there is flat faces, and that would be the lateral faces, or where we can find the lateral area. I drew an example of a three-dimensional figure. When I did this, basically I just started with a rectangle in the front, and then once I created that rectangle, I drew little diagonal lines back from the outside vertexes, and then I connected those points outside and made the outside of my three-dimensional shape, and then I did a diagonal line in and then connected those other 3 points. You'll notice that there are, in my example, there's several faces that we can see, and then there's some that are behind. I drew arrows to where the lateral faces would be. To find, let's scoot that up a little bit. To find the surface area, you need to find the area of all faces and then add them together. So basically, just like when we did a composite or a irregular polygon, how we divided into smaller shapes that we could use formulas to find the area, and then we added those areas up, it's the same exact thing. That's why it's good to understand that a three-dimensional shape, the outside can be flattened down into a two-dimensional shape that can be easily divided. That's where the idea of what a net comes into place. A net is that skin of the three-dimensional shape once it's flattened out into two-dimensional form. So this is the idea of surface area. So now what we're going to do is we're going to write down the steps to find the surface area of a shape. The first step is that you are going to find the area of the front and back. And this is finding the surface area of a rectangular prism. So you're going to find the front and the back. Then you're going to find the area of the top and bottom. Then find the area of the sides. Add all areas together. And then finally, label as units squared. Because we're not yet doing volume, we're not doing the inside piece, we don't do yet to the third. We do cubed when we're actually doing the inside area, but this piece is still the outside. You're still doing a flat edge. Okay. Final thing we're going to do is we are going to create another three-dimensional shape. And actually, let's do a rectangle. Send it back to make it into a rectangular prism. Sorry, I messed up. A little better. It's not great, but you get the idea. That's why it's good to do your notes in pencil sometimes. Alright, so that's connected into my three-dimensional shape. Now, we're going to say that this height here is 2 centimeters. This section here, the width, is 5 centimeters. And the depth here is 8. It's obviously not drawn to scale. So if I were to flatten this shape out, you would have a shape that has a rectangle in the middle, a rectangle here. It would be 4 rectangles down and 2 over. This would be the net.
There we go.
That would be the flattened out section of this rectangular prism. Does that make sense so far? Are we going good? Okay. So now what we have to do is we need to start plugging the values. Let's first look at the top and the bottom, which would be, this would be the top, and this would be the bottom. So if I look at this space here, this rectangle that we have at the bottom, can somebody in the class with a raised hand tell me what would be the length and width? Because remember, length and width is how we find area of a rectangle. What would be the length and width of that one? James?
The length of it would be 5 5 centimeters. No,
Okay.
The length of it would be 8 centimeters, and the width of it would be 5 centimeters.
That works. Okay. So we have this one and this one would be 8 and 5, or 5 and 8, because they're the same. Class, what is 5 times 8?
40.
40. So we have now that the top and bottom are 40 each. Alright, so now let's do the front and the back. So this is the back, this is the front. Can anybody tell me what the front, so look at our shape here, what would the dimensions of the front and the back be? And remembering its length times what? Cody, what would they be? 2 and 5. Good. So we would have 2 and 5. Well, class, what is 2 times 5? 10. So the front and the back, we would have 10 each. Now we need our sides. We have our 2 sides. They're the same. This and this. It's this side and this side. What do we have for the dimensions on our sides? Look at your 3-dimensional shape here. Tanner, what do you think?
2 and 8.
2 and 8. Good. We have 2 and 8. So what is 2 times 8, class? 16. So our 2 sides are 16 each. If there's 2 of each of these, couldn't we theoretically, or couldn't we actually add them all up and then just multiply by 2 in order to get the answer for the total shape? Would that work, guys? Yeah, okay, so what's 40 plus 10?
50.
50. What's 50 plus 16?
66.
So we have 66. We need to multiply it times 2 because there's 2 sides. What is 66 times 2? Adriana.
132.
Adriana. Sorry. 132. And it's 132 what?
Units squared.
Units, but do we have an actual unit present?
Centimeters.
Centimeters. So it would be centimeters squared. Now, here's the thing, guys. We did a rectangular prism. You can actually do the exact same process to find a pyramid, or to find a cylinder, or to find whatever shape you need. Because think about it. If I were, I'm going to cover these notes for just a second. If I were to have a pyramid, pyramids like that, right? A pyramid, when I flatten it out, is the center here, and then it's a point here, point here, point here, point here, and they all come lift together and they meet, right? Don't I have then really a square and 4 triangles? Do I know the formulas to find those?
Yes.
So if I have the distances on these, or the lengths of these, could I then figure it out? Think about a cylinder, like a can. Okay? A cylinder is a circle that you have the top, and then it is a rectangle that connects it. There's a circle and a circle, and then a rectangle that goes across. Think about a soup can. If you've ever pulled the label off a soup can, isn't it just a big rectangle? So couldn't you theoretically just pull that apart and figure out the area for the circles, and then add the area of the rectangle, and you'd have your surface area? So you can use this process to figure out the surface area of any shape you want. It's just a matter of like figuring out, if I flatten this out, what are the different pieces that I have, and can I figure out the formulas for those areas and then add them together. So now, if you haven't done so already, I want you to go back to 137. I want you to count out your lengths and your widths. I want you to figure out what would be the surface area of this shape, and you can test your answer by actually counting the boxes. Alright guys, well thank you so much, and have a fantastic day.